Hello students, today we are going to start the first chapter in the new year, that is the photoelectric effect. We have studied a bit in class 11 chemistry and today we are going to discuss in details the chapter. Now as the name suggests, photo means light, electric means the emission of light, emission of current, emission of electricity, or you can say the emission of electrons due to the effect of light. It was observed that when light falls on a metal surface, suppose ultraviolet light, a light of a high frequency, when it falls on a metal surface, then what happens? Then electrons are emitted from this surface. And if suppose this plate is made positive, then electrons emitted from this plate will move to this plate and a current will be flowing in the circuit. Okay? So this way, this property of the emission of electron when the plates are radiated by a high frequency light, it is called photoelectric emission. The phenomena of emission of electron from metal under the effect of light is called photoelectric effect. Now let us do one experiment. See, this is a setup to study the photoelectric emission. These are two plates P1, this is a plate P1, the metal plate on which the light falls and electrons are emitted. And this is another plate whose potential we can vary from here. This is the commutator setup by which we can vary the potential of this plate. Okay, this potential, this whole thing is used to vary the potential of this plate. And this is the ammeter to measure the current flowing, and this is the voltmeter to record the potential. Okay, now let's start. Light rays are incident on the metal surface. If the light ray are having low frequency, then there will be no emission of electrons. But if light rays are of some suitably higher frequency, then there will be what? Emission of electrons. So electrons will be emitted from these plates. Okay, the electrons will be emitted and these electrons will be emitted when light of high frequency falls on this metal surface. Now see, at first what we are doing, we are keeping this plate positive. If the plate is made positive, then this electron will be attracted to this plate and there will be a flow of electron, and that is the flow of current in this circuit, which we can get it from this milliammeter. From this milliammeter we can get know that current is flowing in the circuit. If this is made more and more positive, then after some time the current will stop. Okay, the current will saturate, not stop, the current will saturate. So there will be a maximum limit of the flow of current for a given frequency. Okay, now see what we are doing. We are making this plate from positive. By changing the here, we are making the plate negative. Okay, now as we are making the plate negative, we will see that still some of the very energetic some electrons which are having very much kinetic energy, they are able to jump from here to here. Some of the very energetic electrons are coming here, and as a result, what we will observe, and as a result, okay, now what we are doing, that we are making it more and more negative. We are making this plate more and more negative, and we will see at a particular potential, let it be V0, the electrons stop coming from this plate. Okay, means the maximum kinetic energy is also stopped, energy electron is also stopped by this potential V0. So E into V0, that is equal to the maximum kinetic energy of the electrons. So E into V0 is the maximum kinetic energy of the electron, and V0 is called the stopping potential. Now if we want to, at the case of stopping potential, there will be no flow of electron from here to here. Now if we want to continue the flow of electron, then what we will have to do? We have to put the light of more frequency. Okay, because if you are at the stage of stopping potential, then even if you increase the intensity of light, there will be no change. Okay, here intensity will not do any change, but still if we want to photoelectrons emission, then we have to increase the potential, then the stopping potential will also increase. Okay, so this graph gives us the relation between intensity and current. See, previously at low intensity, we have this was the current becomes saturated at this intensity, and now obviously the frequency is also fixed, and now what is happening, this is the stopping potential. We have increased the intensity, then current is more. See, current is more, we are getting now more current is increased. But even if current is increased, and if we decrease the potential, we are getting the zero at the same potential. So what I want to say is the stopping potential is same. Stopping potential is same in both the cases. Okay. Even if the frequency, so stopping potential does not depend upon the intensity of light. So what rule we are getting here? That stopping potential does not depend upon the intensity. Even if you increase the intensity, you will get the same stopping potential. Okay. Now let's see what is the relation of it with frequency. Suppose this is the first case. Okay. Now you increase the frequency, you got the same amount of current, but in this case the stopping potential has been increased, because I told you if we increase the stopping potential, then what will happen? If we increase the stopping potential, then what will happen? Then we will see if we increase the frequency, then what will happen? Then the stopping potential will also increase. So what we see, that intensity, stopping potential does not depend upon intensity, but it depends on frequency. It is directly proportional to frequency. Okay, and here we are plotting the graph of the maximum kinetic energy, that is EV naught. EV naught is what? The maximum kinetic energy of the electrons, and this is the frequency. So we will see that this graph of EV naught and frequency is a straight line. And if we trace the graph back, we will see at one point the frequency is becoming zero. At one point the kinetic energy, the maximum kinetic energy of the electron becoming zero, means the frequency of this should be above this point. The frequency of this should be above this point. If you go to lower frequency, if suppose I decrease the frequency, then there will be no photoelectric emission. So if I want photoelectric emission, then the frequency of the incident light should be greater than V naught. Okay, so V nu naught. So this is a Greek letter nu. So the frequency should be greater than nu naught, then only you will get a photoelectric emission. And this frequency greater than nu naught is called threshold frequency. Is called what, students? It is called threshold frequency. Okay. Acha. Now, so from this we say that this is a straight line graph, and this formula of the graph, equation of the graph can be Ek equal to A minus B. A into frequency minus B. Okay, A is what? A is the slope of the graph, and B is the point, and this is the point where the graph cuts the y-axis. Okay, from there you are getting it. Acha. Now, okay, laws of photoelectric emission. The Leonard and Millikan gave the following laws on the basis of their experiments. What is the law? First law: the rate of emission of photoelectron from the surface of a metal varies directly as the intensity of incident light. Okay, we have studied that rate of emission will increase if the intensity of light will increase. Okay, maximum kinetic energy of the emitted electron is independent of intensity. So See, maximum kinetic energy does not depend upon intensity. We have seen that even we are increasing the intensity, the stopping potential is same. So what is stopping potential? Stopping potential formula we know, it is actually V0 E into V0. Okay. So this V0 will be same even if we increase the intensity. So that is why this point is given, that maximum kinetic energy, that is EV0. So EV0, that is the maximum kinetic energy, does not affect upon increasing the intensity. The maximum kinetic energy increases with the increase in the frequency. Yes, this we can see here, that this stopping potential will be changing if we increase the frequency. So if the frequency of the incident light is increased, then stopping potential, or you can say maximum kinetic energy, will also increase. Means if we increase the frequency, then we will get more and more energetic electrons. We will get more and more energetic electrons. If the frequency of incident light is below a certain value, then no photoelectron is emitted. Yes, if the frequency of light is below a certain value, and that certain value is called threshold frequency. So if the frequency of incident light is below the threshold frequency, then there will be no thermoelectric emission. Okay, there will be no photoelectric emission. Okay, failures of wave theory. According to the wave theory, energy carried by a beam of light is distributed uniformly. Thus, when light falls on a metal surface, the energy of the wave should be transferred uniformly to all the electrons, and so all the electrons should emit out at once. But this does not happen. Okay. So what happens? The electrons come out slowly, one by one, slowly. But why it is so? Why it is so? This problem has not been explained by the. So why it is so? Why, according to wave theory, all the electrons should come out all at once, but this is not observed. So this is the failure of the wave theory. Again, the wave theory suggests that any light of frequency can be able to emit electron. So we have seen in that there should be a minimum frequency, and light below the minimum frequency will not be able to emit electrons. But here what we see, according to wave theory, that there should be no such criteria, but this criteria is. Okay. So explanation of threshold frequency was not possible by the help of wave theory. So these are the, now let's see. So we have seen that photoelectric emission. Now what is the cause? Why the wave theory failed? Then what will be the new theory that will be able to prove? Now the scientists were searching at that time. And now there came a scientist, Max Planck. He has put a revolutionary theory which is called the quantum theory. He said that light is made up of small bundles or packets, and these packets were called frequency. These packets were called photons. So light is made up of energy packets which have no rest mass. These photons don't have any mass, but they have energy. And the minimum energy of a photon is h nu. And the minimum energy of a photon is h nu. What is h? H is Planck's constant and nu is the frequency. And if the energy of the electron, a photon, is more than this, then it should be a integral multiple of h nu. Means suppose we can have the energy as h nu, 2h nu, 3h nu, but we cannot have any photon whose energy is 1.5 h nu or 7.5 h nu or 13.5 h nu. No, this is not possible. The energy of every photon should be an integral multiple of h nu. Okay. So Planck gave the hypothesis that the energy that we are getting from the photon is h nu. Okay, it depends upon the mass. It does not depend upon the mass, because it is depend upon the frequency, because photons don't have any rest mass. Einstein's explanation of photoelectric emission. On the basis of the quantum Planck theory, Einstein has explained that Einstein had explained that energy of every, according to this theory, light travels in form of small bundles or packets called the photons. The energy of each photon is h nu. Energy of each photon is h nu, and where nu is the frequency. Planck's universal constant, h is the Planck's constant. So intensity depends upon, now the intensity of light depends on the number of photons. Okay, if there are more photons, then it means their intensity of light is more. Okay, now when a photon falls on a metal surface, then it transfers whole energy in the form of h nu to any one of the electron. Okay, so when a photon falls on a metal surface, then it gives its energy, which is h nu, to any one of the electron, and by taking the electron energy, the electron comes out if the energy is sufficient. Okay, now what happens here? See, suppose one photon is coming, hitting the electron with an energy h nu. Now from this energy, a part of the energy is used in doing work. In a part of the energy is doing work. What is the work? In the emission of electron. Overcoming the, because when the electrons are emitting, so there is the positive charges also inside the metal. So electron have to overcome the electrostatic attraction with the positive charges, and after overcoming all this only the electrons can emit. So this is h nu is equal to this work function, that is the energy required to overcome the electrostatic forces, and the difference means to whatever is the difference. Suppose this is 100 joule, work done 80 joule, and whatever is the difference, the electron comes out with this difference as the kinetic energy. So difference in the energy, suppose h nu is the energy given to the electron, w is the work function, then the difference of this, that is the h nu minus w, this h nu minus w will be actually the kinetic energy of the emitting electrons. Okay, this will be the kinetic energy of the emitting electron, and w is equal to h nu 0, that is the minimum frequency, threshold frequency. Now what is w? How to calculate w? The w is equal to h into nu 0. So w is equal to h into nu 0. So h into nu 0 is what? Nu 0 is what? The threshold frequency. The means we have to put light of this minimum frequency, then only we will have the thermoelectric emission, photoelectric emission. So from here, if in place of w, if I write h nu 0, so our equation becomes Ek equal to h nu minus h nu 0. From here we can take common. Now see, this Ek is actually what? This is the kinetic energy of electron, maximum kinetic energy. So this can be E V max square, because we know kinetic energy is half mv square. So from this is the Einstein's photoelectric emission. Means the maximum kinetic energy is equal to h into v nu minus nu 0. What is nu? Nu is the frequency of the incident light, and nu 0 is the minimum frequency, that is the threshold frequency. Okay, so nu is the frequency of the incident light, and this is the threshold frequency. From here we got this is the Einstein's photoelectric emission. Okay, acha, and see, now Millikan worked further on the Einstein's experiment, and he had plotted a graph of the stopping potential and frequency. He had plotted a graph of stopping potential and frequency, and this graph comes out to be a straight line. Okay, now see, we have seen that half V max square equal to E naught E mu 0. So, and if we in place of the Einstein equation, if in place of Einstein equation I put this here, then this will become what? E V naught is equal to H into V minus V naught. From here we can get this. Now this is the equation of this straight line, and so this is what? H by E is what? The slope of this line. Now if we can calculate the slope of this line in any other way, then putting the value of E, we can get the value of Millikan's constant. Okay. Now energy and photon. See, E equal to h nu equal to mc square. We know from Einstein's relation. So from here, m is what? Although photon has no rest mass, but since it has energy, so this energy is called kinetic mass, means mass of the photon due to energy, because photon generally don't have any rest mass. So m is equal to h nu by c square. So from here we are getting that this is the mass, and this is the formula for the momentum of the photon. Okay students, have a nice day.